Let's start talking about circles by looking at some basic definitions. Now we know that a circle is formed by all of the points that are the same distance from the center of the circle. And if we take a line segment that goes through the center of the circle and has endpoints on the circle itself, then we have a diameter of the circle. A line segment that has an endpoint on the center of the circle and another endpoint on the circle itself would be a radius of the circle. And the distance around the outside of the circle is the circumference of the circle. Now all three of these things are linear measures. They're measures of length. Pi is an irrational number that is the ratio of the circumference of a circle to its diameter. And this ratio is going to be the same ratio for every single circle, which is why pi is a constant that's approximately equal to 3.14. Now that relationship between circumference and diameter and pi actually gives us the formulas that we need to find the circumference of a circle. So if we want to find the circumference, which we know is the distance around the circle, we can either take 2 times pi times the radius of the circle, or we can take pi times the diameter of the circle. And that's because the diameter of the circle is the same thing as twice the radius. So these two formulas are interchangeable. So suppose we have a circle and we know that the radius is 7 inches and we want to know the circumference. Since 7 inches is a measure of radius, we can say that the circumference is 2 times pi times the radius of 7, or 14 pi inches. Or if we knew the diameter of the circle, which would be 14 inches, we can say that the circumference is pi times the diameter of 14, or 14 pi inches. Now what if instead of finding the distance all the way around the circle, we only wanted to find the distance part way around the circle? In that case, we're looking for something called the arc length. So to find the arc length, what we will need to do is find the circumference of the circle, that's the distance all the way around, and then multiply that times the fraction of the circle that's taken up by the arc, which will equal the angle that the arc is formed by divided by 360, since there's 360 degrees in the whole circle. So suppose in this case this arc is formed by a 120 degree angle, and we still have our 7-inch radius circle. So to find the arc length, we can take 120 divided by 360 and multiply that times the circumference, which we've already found to be 14 pi. And in this case, we would see that the arc length is 14/3 pi inches. Area of a circle is the amount of space taken up on the inside of this two-dimensional figure. To find the area, we'll take pi times the square of the radius. So suppose this circle has a radius that measures 3 meters, and we want to know the area. We'll take pi times the square of 3, which is 9 pi square meters. Remember, area is measured in square units. Now what if instead of wanting to find the area of the entire circle, we want to find the area of part of the circle, kind of a wedge shape? Well, in this case, we're looking for the area of a sector. And just like with our arc length formula, for the area of a sector, what we're going to have to do is find the area of the entire circle, and then we'll take a fractional part of that, which is defined by the measure of the angle divided by 360. So suppose we still have our circle that has a radius of 3 meters, and we want to find the area of a sector that's formed by this 120-degree angle. Well, we can take that area that we've already found, which is 9 pi, and multiply it times 120 divided by 360. So our area of our sector will be 3 pi square meters. There's some other things that we're going to look at with circles and angles that are some kind of interesting observations to make. For example, suppose we have a circle and we have a diameter of that circle. Now that diameter is a line segment that has endpoints that are on the circle. From each of those endpoints, we will draw an angle that has a vertex that's on the circle. Now if you look at that angle that's formed, you'll notice that the angle is a 90-degree angle. And as it turns out, that will always be true. If we form an angle by having a vertex on the circle and our line segments that have endpoints on the ends of a diameter, the measure of that angle will always be 90 degrees, no matter where on the circle that angle is. Now there's some other interesting things that go on with angles inside circles, but we're going to need some definitions before we talk about them. Now we know that a circle has a center. If we draw an angle that has a vertex at the center and endpoints on the circle, we will have created what's called a central angle. And if we draw an angle that has a vertex on the circle and endpoints on the circle, we have what's called an inscribed angle. Now take a look at those endpoints. If we take the endpoints on the inscribed angle and we make them the same endpoints that we have on the central angle, then we've got a relationship that will always be true, which is if this central angle and the inscribed angle subtend the same arc, which means those endpoints for each of those line segments are shared, then the central angle's measure is always going to be twice the measure of the inscribed angle. So suppose we have an inscribed angle of 50 degrees, and we want to know what the measure of the central angle is. Well, because they share those endpoints, we know that the measure of the central angle has to be twice the measure of the inscribed angle. So the measure of the central angle has to be 100 degrees. So as usual, we're going to get a chance to practice some of this in class.